In the last 100,000 years, the tall mountain called Uraruncu in the central Andes has been quiet. Its most recent eruption happened more than 250,000 years ago. And yet, Uraruncu is showing signs of life, releasing gas plumes and producing earthquakes. Thanks to data collected over the past 2 decades, scientists now have a better understanding of what's happening inside this so-called zombie volcano. To get to the bottom of Uraruncu's unrest, researchers turned to satellite radar imagery taken over the span of more than 20 years. This type of radar can penetrate clouds and even solid rock, allowing scientists to measure changes in a volcano's shape over time. The new analysis revealed that between 2000 and 2021, forces inside the volcano lifted and then lowered a region near the summit, measuring about 93 miles, 150 kilometers wide. This created a broadly shaped dome-like structure that looks like a sombrero. Though the radar data alone couldn't explain what was happening beneath the surface, the team had a hunch. Based on previous studies of Uraruncu, they hypothesized that the mountain's rumbling was the result of magma pushing up against the roof of a magma chamber, located about 4.3 miles, 7 kilometers below the summit. That magma chamber was likely created by a batch of magma that stalled out while trying to make its way upward through the solid rock. But to test their idea, they needed more data. Between 2016 and 2018, scientists recorded seismic activity around Uraruncu. Their goal was to identify the size and shape of the magma chamber and figure out if it was pressurizing in a way that could lead to an eruption. They found that magma was indeed pushing up against the roof of the magma chamber, creating small earthquakes as the rock cracked and shifted. But something else was going on too. Analysis of the seismic data revealed that there were also vibrations caused by the movement of fluids. Based on the speed at which the fluids were moving, the researchers inferred that they were probably water and/or brine, which suggested the presence of a hydrothermal system. And because these fluids were vibrating at a range of different frequencies, they likely flowed through a network of interconnected cracks, rather than a single channel. Finally, the team developed a computer model to simulate how rocks respond to different pressures and temperatures deep underground. Their model showed that the observed seismic signals could be explained by pressure and temperature changes associated with the movement of both fluids and magma. Together, the evidence painted a picture of a hydrothermal system that was connected to a magma chamber, but not in the way you might expect. Instead of the previously held idea that magma chambers are sealed off from the surface, this research suggests that Uraruncu's magma chamber was likely part of a larger network of communicating pathways. That network facilitated the exchange of heat and fluids between the magma and the surrounding rocks, allowing hot water and gases to rise from deep within the earth and cool as they moved upward. And it turns out that this interaction between magma, hot fluids, and surrounding rocks may be an important part of the story behind many dormant volcanoes. We think this is a common process that we have discovered here at Uraruncu. We think it's one of the main reasons why there are so many dormant volcanoes, said co-author Simon Day, professor at University College London, in a statement. These systems appear to keep the magma alive and prevent it from becoming extinct. The findings suggest that, although Uraruncu is considered a zombie volcano, it's not technically dead. Like other seemingly active dead volcanoes, it doesn't have a magma chamber filled with fresh magma, but instead it has a magma residue and a hydrothermal system that circulates heat. However, the system isn't completely closed, meaning that magma can still make its way into the chamber. So while an eruption isn't imminent, it's possible that Uraruncu will stir again. And thanks to this study, scientists are a step closer to understanding what makes some volcanoes rise from the dead while others stay buried.